Okay, let's get started, guys. So we'll start with strings again. So let me share my screen. Cool. Today I will finish my class in half an hour. Why? Yeah. Just like that. I'm hungry. Just kidding. We'll do it. Where is the code? String sort code. Sort names, let's see. Huh? Okay. Thank you. So now see the data, this is a code in which okay, Hardik, Abhinav, some interesting suggestions, I will do them. It's like, I figure out I get used to some simple things and I just repeat the same things. So yeah, the data structure here, if you see, it is the names, it's a two-dimensional array. The number of rows in this data structure, it is, max number of rows. So if you see, the number of rows is max number of names. And here in our program, so this is, if you hover over this, you will see that we have the number of names is 100, and each row here, it stores a name, and the maximum length is 50. So this whole dimension from here to here, it is 100 and it is 50. That means we can store 100 names maximum. And each name length is fixed to 50. And in some cases, we will use, depending upon the length of the name, so we use some number of elements in each row. And followed by that, you will have a null character to indicate it's the end of the name. So you can see that there could be a lot of wastage in the space that is allocated. There's a lot of wastage in the space that is allocated. That is one. So we want to see how we can save the space. That is, we don't want to have blank spaces in each row. And one question, so the variable, the array names, it is allocated memory in the, where is it allocated memory? The variable names, it is allocated memory on the stack in the activation record associated with the main. So now we want to come up with an alternate strategy where we read a name and want to allocate only that much amount of memory that is required for that name. So towards that, we will use an alternate data structure where if this is your memory, so here for the sake of simplicity, we will use n of 0 is, it kind of points to n of 0, n of 1. So this n of 0 is a character pointer. So these are all character pointers. And so we will, in the memory, there is a section of memory called as heap. And we use a function called as Malloc to allocate memory from this heap section. So let's see how this goes as we proceed. So char star. So now what we are doing is we are defining an array of character pointers. For the sake of simplicity, this is a 1D array. This is an array of character pointers. I'm just using capital N as a shorthand for the names variable. So this holds an address. N of 1 holds an address. And N of 2 holds an address, so on and so forth. Yeah, the array itself, every element of the array, it holds an address. Think of it as every element of an array, it contains a house address. We will see address to what. Okay, so this declaration on line number 59 means array of character pointers. Array of character pointers. So now let's go to the names function. So let's go to the names function. And so we have array of character pointers, and we are going to change this code while scanf. So we read a name into this temp name variable. We read a name into this temp name variable. And then what we do here is, what do we do? Names of number of names is equal to malloc strlen temp str. So if you see stringlen gives, if you go look at the man stringlen, man strlen stringlen function, it gives the length of a string excluding the null character. Okay, so you can, if you read here, stringlen function calculates the length of a string pointed to by s excluding the terminating null byte. So we want to store this temp name. So when we do an malloc on line number 14, so let's say the name is Sardak. So temp name stores Sardak. And then, so when you do an malloc, so the number of characters in Sardak is 7 plus 1, 8. So a chunk of memory from the heap, let's say the base address of this chunk of memory is A1. So malloc returns a chunk of memory here, and the base address it returns, and that base address we are storing here. Are you with me here? And we say, we do explicit typecasting, telling that the chunk of memory that we get, the address that we get, it's a pointer to a character. So we do this char star, that is implicit, explicit type conversion. And after that, what we do is string copy. It just says that the address is a pointer to a character. The address that we got, Malloc returns an address, and this typecast says that the address is a pointer to a character. Not yet. Sardak is not yet stored in the heap. So we have to copy Sardak from stack to heap. Let's copy Sardak from stack to heap. So names void star. So number of names temp str. So when you do this copying, temp string, the temp name, it is present, it is allocated memory on the stack. And now we are copying it to the new place. Default is void. Because the memory that is allocated, it can be for any purpose. So if you see man, so you see here, void star, this Malloc and free are important. And they are in stdlib. You just typecast it, that is, so it returns, when Malloc says I'm returning a chunk of memory, the base address of a chunk of memory, I don't know what that points to. The base address, it can point to, the base address can point to an integer, it can point to a character, or it can point to something else. So you are telling the compiler that, the address that we got, that address at that place we want to store a character. So that's the reason we are, it's like, because Malloc, the memory, so using Malloc, you can get memory to store apples or oranges or, bananas or whatever it is. Malloc doesn't know why you use that memory for. Heap memory, it's a logical memory in your RAM, where logical space in your in your RAM, from where memory is allocated. It's a logical place. It's like logically you say, yeah, that's true. We are allocating space. So the difference between, there's a big difference between stack and heap. Where is number of names variable on line number 10 allocated? Where is it allocated? NO names and line number 10. It is allocated on stack. When you are out of the read names function, what will happen? The memory that is allocated will be released. Yes or no? But the memory that is allocated using Malloc, it will be there until you explicitly free it using the free function. We will see free function in some other class. Until you explicitly release it, it will be available for you. No, there is a chunk of memory. Don't mix up things. The chunk of memory, you allocate a chunk of memory using, it's not like global variable. The memory that is allocated to a global variable lasts throughout the program lifetime. But the memory that is allocated to heap lasts until you make a call to free. Malloc gets the memory from the heap. Okay. And then we do a string copy. And now we have to read. We'll continue like this. Are you okay with the code from line 13 to 17? On line 14, we are getting memory from the heap. No, heap is not the hard disk. No. It's just your RAM. Some part of the RAM, you logically think of it as heap. All we are doing using Malloc is to get a chunk of memory. Why are we using string len? No, because Sardak, how many bytes you want? how many bytes of memory you want to use, you want to request. strlen gives the length of the name and +1 for null character. Okay, yes, first question. Please so what is the parameter for Malloc? What is the parameter? The number of bytes we want. The number of bytes we want to request. That is what is the parameter for Malloc. And what will Malloc do? There is a section of logical section in the memory which is called as heap. From the heap, it allocates that the requested number of bytes and returns the base address. Are you with me? The return address of Malloc. What does Malloc returns? Are you with me? It returns the base address. Okay. So now the memory that you asked for Malloc, please listen. Okay, the memory that you ask from Malloc, you can use it as to store a character. You can use it to store as an integer. You can use it to store some other thing there. So there is no return type there. So that's the reason void star means it's a pointer. That's all. I don't know what it means. It's just a pointer. It's just an address. That's all. Just think of it as void star. Don't pay attention to that. Okay, it's just it's just like a placeholder void, because the address can be you might be storing a character, integer, float, double. So it cannot be the case, Malloc return type cannot be int star or float star or double star or char star. It cannot be any of these things, because Malloc doesn't know why you are using it for. So that's why it says just void star, and then you typecast it to the address based on the object that you are storing at that address. You do char star. Like for example, if you want to store an integer there, so you do something like int star Malloc size of int. Okay, so that what this statement says is you are requesting Malloc to allocate memory which can hold an integer. You get an address, and that address you typecast it to int star because your plan is to store an integer. Are you with me here? Okay. So that's all. So now you have your so this is how the read names function will work. And let's say now we will move and work with the print names function. Okay. Remember, we want to pass so in your heap memory, so what happens is we will go through the code. So the first time, so Sardak is allocated memory here. When you make one more Malloc call, maybe, Patanjali is allocated memory here, so on and so forth. Yes, that +1 will create space for the null character. So you are passing the base address of each of the strings in this print names function, and you will do the printing. And that's what is happening here. Okay. Now for the time being, let's okay. So now let's run this code and see what happens. Array, we changed the source code, sort names. Okay. Dot slash a dot out less than names dot text. So it just read and printed the names on the screen. Okay, so you're all good. Now let's try to see what is happening underneath. Okay. So now we'll put a breakpoint in read names function. Continue. Next. So now see, if you do print, even let's see, next. If you do print names, print temp name, okay, print temp name, you'll see some random stuff is there in the string temp name. And now you are using the scan, and then look at print names of 0. So when you print the names of 0, some again, some stuff is there. Okay, names of 0. We'll see. So now we go to next. So let's say we enter Sardak. So Sardak is now on the stack. Temp name. Okay, so temp name is allocated memory on the stack. So, so it's on the stack. So now, if you do see names 0, so now memory is allocated on 7 bytes of memory, 7 or 8 bytes of memory is allocated on the heap, and the base address of that 8 byte chunk of memory is stored in names 0. Okay, 6B0. Are you with me here? Are you all with me? This is 6B0. So now let's continue. Next. So now when we do temp again, okay. So let's say it's Meghna. So now you do print temp name. You will see now Meghna is on the stack. So now we request memory from the heap. Print names 1. You see now another address. So we got a chunk of memory, and the base address is of the chunk of memory is 6D0. All right. And then next, if you see print names 0 now and print names 1, you see this. So these addresses, they are pointing to, this is this address. Yeah, the addresses are, they are pointing to some space in the heap. The names are stored in the heap. String copy is copying the string that you have stored in the stack to heap. When you read it to temp name is memory in the is allocated memory in the stack. From there we want to copy it to, it's like a temporary buffer. Temp name is a temporary buffer. We read the name there and we find the length of the string, and we from stack we copy it to heap. It's not copying the base address, it is copying from the base address. See, GDB is powerful. So GDB knows that you are working with strings. So GDB, if you see print names 0, the actual content that is present in names 0 is this address. The actual thing that is present in names 1 is this. But GDB is, it is smart. It is showing us at the starting at this address, this is the string it got till it encountered a null character. We are not storing the Sardak in names 0. You understand? This address is present. But GDB is smart, so because of that, it is going to that address and showing what is present there to help us debug the program. Are you with me? Does it make sense, all of you? Sardak is not stored in 6B0 starting from address 6B0. At 6B0, S is present. At 6B1, A is present. At 6B2, R is present. At 6B3, T is present, so on and so forth. Okay, so that's all it is. Okay, so this is how dynamic memory works. Are you all with me on this? How this read function is happening? How we are allocating dynamic memory? Okay. So now, if you're all with me till this point, then so let's get back to dynamic means we are allocating memory on the fly, not before. Names is an array of character pointers. That's true. So now let's go to okay, let's see. That's what Ashmit. So here it's just for GDB is smart. It wants to help us debug the program. Otherwise, if it just gives this address, then you will. It's just to help us debug the program. It goes to that address and it finds the string and it is printing on the side. Okay, so now let's fix the bubble sort code. So char star names, number of names. So this is all good. So now here we want to compare util kriti, util till the null character, no? Yeah, that's all. Okay, did you see the change on line number 44? Names of I base address, names of I plus 1 base address. Now I have an interesting question for you. Let's see the picture here. Let me draw the picture here. So okay, so let's see. So this is our heap and this is our character array, a array of character pointers, N0, N1. So here you can see 6B0, 6D0, and so let's say 6B. So here, this is the base address. So Sardak present here. This is 6B0, and this is Meghna 6D0. Okay. Are you with me? Are you fine with this picture? This is heap. And since this names array It is a local variable. This is coming from the stack. So when you want to do the sorting, so Meghna appears before Sarthak. So we want to do the swap. Do you think this will work, swapping this way? Whether the code from 52 to 54, will this work? In this particular case, it will work because the number of characters in Sarthak and Meghna is exactly same. So because of that, when you can move Sarthak to Meghna and Meghna to Sarthak without any problem. But let's say, you know, Sarthak is Sarthak, S-A-R-R-T-H-A. Then what happens is when you try to copy, Meghna can go to Sarthak's position, but not the other way around. Because the number of characters that is allocated is exactly that, right? So this requires 3, 6, 8, 9 characters, and when you try to copy Sarthak to the chunk of memory allocated to Meghna, but the memory is less. So because we did Malloc, Anand, thank you. Are you all with me on this problem? We cannot simply do the string copy code. It doesn't work. So what should we do? How should we solve this problem? How should we solve this problem? Yes, thank you. So right now the story is, so we have to move 6D0 here and we have to put 6B0 here. Okay, 6D0 here, 6B0 here. Does this work? Can you swap the addresses? Then 6D0 Meghna will be up and Sarthak will be down. So that's all. So let's write this code here. So here, char star temp ptr is equal to name psi. Name psi is equal to names I plus 1 names I plus 1 is equal to temp ptr. That's it. That's all, no? Will it change? There's a challenge problem for you here. Challenge problem. Write a swap function for the following. Okay. So now let's compile. We right now, right, we are writing this one, you know, I want something like, we just wrote the swap code, that's true, yeah. But the swap code is for changing pointers. It's not for copying strings. We are changing pointers. Earlier we are copying. Yeah, we are just exchanging the addresses present in the two locations. That's all. Yeah. You see what we want here on the top? We want 6D0 to move. We want 6D0 to move here and 6B0 to move here. In the challenge problem, Right now we are doing a swap here itself, right? I would like you to write something like swap, no, the two pointers that we have. Like I want to write a swap function which swaps which takes two parameters, whatever, I don't know what parameters you give, but name psi plus one, they should swap their positions. Yeah, so Anusha got it right. We pass name psi, which stores the address of, so it will compare the two names. Yes, Anusha, you are perfectly right. Did you get the challenge problem? Instead of code 56 to 59, I want you to write a swap function which does the equivalent of codes 56 to 59. There is a good lesson that you have to learn when you write this swap function. That's the reason I'm asking you to do it. Okay, shall we move on? Yeah, we need pointer to pointer, exactly. It's so GCC sort names.c dot a dot out. So it's not sorted. Yes, it swapped the addresses. You're swapping the addresses. We didn't compile it. Something went wrong. Huh? Who got Abhinav? Who got mixed up? Vrunda. Yeah, so Vrunda got mixed up. Yeah. No, these are the changes only on line 42. Why number of less than? Oh, okay. Name site. But this problem should have been there before, no? Did I miss? Let's see. Yay, we got it. Good catch, guys. Because we are using names of I plus 1. Are you all with me here? Did you see the bug? Okay. When you use number of names, we go out of bounds. Think, Anika. You should think, no? You should think and see why What will happen if you use number of names versus number of names minus 1? Think about it. Okay, so far are you all with me on this program? There's some small bug there, but happy? You understood how Malloc works? Because that is going to be very, very fundamental to many things that you do, in the next few sessions for the rest of the course, and also in your data structures course, you'll just be using left, right, and center all the time. But one thing we didn't solve is our array size is still fixed. The maximum number of names, it is still 100. Can we solve this problem? The max number of names? How can we solve the max number of names problem? So one way is, which is not quite elegant. So enter the number of names, but we need to know the number of names before now. So we need to know the number of names before. So this is a kind of a, not a great fix for this code. Great. So are you with me? At least Abhinav has a good suggestion. We will see. But right now, are you with me on this code? That if you know the number of names, then we can use variable length arrays to solve this problem. But if you don't know the number of names, that is an issue, right? So how can we solve that problem? If you don't know the number of names, how can we solve the problem? So what we can do is, line 44, we are not comparing names array. We are passing the address of the ith string and the i+1th string for string compare. Okay. So what do we do? So what we do is we start with an initial estimate. So we start with an initial estimate. So we initially say we allocate 50, an array of 50 character pointers. We thought initially, hey, let's say that we can work with that. We make an initial estimate that we have 50 names, and once we run out of space, we can do so. When we do is we do what is called as an malloc, and then we can do what is called as a realloc to expand the memory from 50 to 75 entries. And when we run out of it, maybe you can add 25 more, and we have to do what is again one more realloc. And this strategy, realloc, could be an expensive operation. So realloc means we will see in the next class. Do man realloc, Rohan. So there are many ways of doing it. So like maybe we can say 50 to 100 to 200 to 400. So there's a different ways of expanding. But this is, here we are doing plus 25 every time. This realloc is an expensive operation. If you are very aggressive in expansion, what can happen? If you are very aggressive in expansion, what can happen? I mean, think out of OJ. So before all those things happen, like for example, if the number of entries are 201, and when you double it from 200 to 400, lot of memory goes waste. Yes or no? It's not easy to free the rest. You cannot do it. That's again a pain. Do you see here, like when we double it from 200 to 400, 200 200 bytes of 200 units of memory is lost. But why are we concerned about memory? Memory is computer's problem. Realloc also allocates in heap. So, but if you use this approach, then what happens is, you at some point you go from 200 to 225. So the wastage is less. Are you with me here between the two strategies? Here, when we do aggressive expansion, there's a chance that we can do pretty bad. Lot of memory wastage. So here, when we do conservatively, we save on memory, but the number of reallocs increase and the reallocs are expensive. Are you all with me here? The trade-off? That's what I'm telling you. Increasing by 1, it's not an option because the number of reallocs that you make, it will make your system pretty expensive. No, we give the memory. How much more memory is required, we tell realloc. It's not fixed. It's in our hands. So in the next class, we will come up with a strategy to solve this problem. We will adopt this approach. So we adopt this approach and we see how to write code which adopts this approach. Yeah, we can change the amount of memory increased in every realloc. It's possible. Someone said, Vinkesh said, memory is not our problem. Huh? See, your computer has 16 GB of RAM or 8 GB of RAM. Then after some time, what happens if you run out of memory? Okay, so memory is pretty much your problem. Increase memory, expand RAM, make money. How much ever you delete, no, it's not. And also deleting old programs, you are deleting it on your hard disk, not on your main memory.